So we are doing volume of known cross-sections. Number 2 says, find the volume of the solid whose base is bounded by the graphs of y equals x plus 1 and y equals x squared minus 1. The cross-sections are perpendicular to the x-axis. They are squares with the bases lying in the plane. So the key to all of these is always to have a good picture. Okay? You should graph something out, and I would always suggest doing it by hand if possible, and this one is something we can do by hand. So let's graph this thing. They gave us 2 lines that our graph is going to be between. X plus 1 and x squared minus 1. Show me with your arm, what does x plus 1 look like? That's a line. What's my y-intercept going to be? At 1. So I'm going to make a little graph right here. This is where my first graph is going to go. It's going to start right there at 1. The slope is 1, so I'm going up 1, right 1, up 1, right 1, up 1, right 1. Down 1, left 1. Ugly graph, but there it is. I'm also graphing y equals x squared minus 1. Show me with your arm, what does x squared minus 1 look like? It's a parabola. What's the minus 1 going to do to it? Make us down 1, so we're down here. There's my starting dot. I'm going up 1, left 1. Up 1, right 1. Right 1, up 3. 1, 2, 3. Cool. Here's my graph right here. And so you need to find the area that's bounded by those 2 lines. Hopefully it's pretty easy to see that the space they are describing is this space right here. That whole part. There's no x-axis or y-axis involved. It's just that guy. Everybody good for there? We are finding volume. What do you need to do in order to find volume? Integrate the area. So my goal is to right here write the area. That's where my area is going to go. I need to know one other thing before I jump into finding the area. I need to know what are my bounds and are those x values or y values. So the key to doing that is deciding where are you perpendicular to. So in this case, I am perpendicular to the x-axis. Show me with your arm, what does perpendicular to the x-axis look like? Those are vertical lines. And so your graph is going to go perpendicular to the x-axis. So we're going this way. I am making, what's it say? Squares. And so you're going to have squares that look like this. And then here your square is going to look like this. And then right here your square is going to look like that. Okay, it's hard to see at times, but that's my shapes. When did I start to make those squares? When did I start to stack them? -1 until 2, because this ordered pair right here is the ordered pair 2, 3. I want the x values because I was perpendicular to the x-axis. I stacked them on the x-axis. So -1 and 2, those are x values, so this is a dx problem. All I need to know left is the area of my cross-sections. And my cross-sections are squares. Take a second with your neighbor and see if you can finish that thought. Noah, how do I find the area of a square? What's my formula going to be? Yeah, your base squared or your side squared or whatever letter you want to know. That's his formula. It's a real simple formula. It's something squared. All he needs to know is his base or his side or whatever he wants to call it. It doesn't matter. He needs to know his base. And so think about your picture. Your picture is so important. Where did we make the base of our squares from? Well, we went from this line to that line. We went from this line to that line, from this line to that line. So, Nick, where did I start to make my line from? From x plus 1. We went from this pink line because we always go top to bottom. And so you went from x plus 1 to where? Yep, and what do I need to do with that? Subtract. Top minus bottom, and he said x squared minus 1 in parentheses. That's his setup. If he wanted to, he could just type that into his calculator just like that with all those parentheses. That might be a little bit annoying, but we could. If you want to, you can distribute that negative sign. That would make that negative x squared and a plus 1. And so I'm going to square negative x squared plus x and then plus 2, because I got 2 of those things. And if I do that, it's going to get me the answer of 8.1. Type that in and see if you can get it. So I'm going calculator. Math 9. I'm integrating from negative 1 to 2. In parentheses, I am taking negative x squared plus x plus 2. Close the parentheses, square it. I throw a dx at the end. I hit enter. I get 8.1 just like I thought I was going to. Questions was set up there on number 2. Everybody seeing the basics? Integrate the area. If you draw your picture correctly, everything else from that is pretty much the same thing every single time. You got to get your setup going correctly. If you can do the setup, the rest should be easier. All right, let's flip to the back side. So the front side is all with respect to x. If you need some more practice with that, it's available to you there on the front. The back side's a little bit harder because on the back side, we are doing them with respect to y. So on the back side, let's go down to number 6 and see what we can do with that one. Find the volume of the solid whose base is bounded by y equals x cubed, y equals 0, and x equals 2. The cross sections perpendicular to the y-axis are isosceles triangles with a leg lying in the plane. Draw your picture first. Try to figure out where are you bounded by. Draw that out and see what you can do with your neighbor. Show me with your arm, what does y equals x cubed look like? That's that guy. And so if you don't remember, you can just plug in some values. But if I plug in 0, I get 0. I plug in 1, I get 1. I plug in 2, I get 8. And so that shape looks something like that. I am also bounded by y equals 0. And so this is y equals 0. Yeah, if I can draw it straight. Y equals 0. And I'm also bounded by x equals 2. All right, so my picture's not great because it's so small. I would have probably done a better job if I would have hand-drawn this instead of using the graph. But there's my setup. This is the bounded shape, this spot right here. That's what I care about. The cross sections are perpendicular to the y-axis. Show me with your arm. What does perpendicular to the y-axis look like? This is y-axis. We are stacking on the y-axis. When you hear perpendicular to the y-axis, think stacking on the y-axis. So when I integrate, because that's how you find volume, you integrate area. You're stacking on the y-axis. So this is a dy problem because I'm stacking on the y-axis. From when until when am I going to draw my right triangle or my isosceles triangles? 0 from right here, that would be a triangle, and then I'd have another triangle right there and another one right here, and they would keep going up all the way to that point right there, which is 2, 8. And so the number I want there is the y value, 0 to 8. Makes sense where I'm getting these numbers from. The only other thing I need to do is I need to find the area. I want the area of my isosceles triangle. Try to figure out what that formula would look like, what you would need to plug in. You know what the answer is. It's 1.6. See if you can do that without me. Before we get too far, a reminder that this is a dy problem. So if it's a dy problem, you are not allowed to write x values. You're not allowed to write x in your integral. Your integral has to be in terms of y. So I've got this line here. This is y equals 0. This is x equals 2, which is okay. 2 is fine. But what I can't have is the x cubed. If this is a dy problem, I need all of my equations to be x equals problems because that means y will be in my problem. What do I need to do in order to get x by itself? Cube root it. So you could also say it is y to the 1/3. So this pink line that I've drawn is y to the 1/3. That's going to be important. We are finding the area of an isosceles triangle, which seems fancy, but it's not. This is an isosceles triangle. It says with a leg lying in the plane. So it means this. Oh my gosh, I can't draw triangles. Let's try a third time. Cool. This is an isosceles right triangle where the leg, the thing on the bottom, is going to be the same thing as its height. What is the formula I'm going to use to find the area of that triangle? 1/2 base times height. But since it's an isosceles triangle, the base and the height are the same. So you could say 1/2 base squared or leg squared or whatever you want to call it squared. So the thing I'm going to integrate is 1/2 something squared. All I need to know is how long is that leg or that base or whatever you wanted to call it. Where did I make the base of this leg from? Which line did I start at? 2. I start on the right here. I went from 2 to here, from 2 to here, from 2 to here. From 2 minus the left line. What's my left line going to be? Y to the 1/3. 2 minus y to the 1/3. That is what I'm plugging in right here. 2 minus y to the 1/3 power. And so to type this in, I know what the answer is going to be, but just so we can see it, Math 9. We are going from 0 to 8. Oops. Let's try 8. 0 to 8. Inside the parentheses, it's 1/2 base squared. So if I wanted to, I could type it in as y1. I'm just going to type it in right here, 2 minus y to the 1/3 power. Don't forget to square it. I want all of that squared because it's leg squared. And then dx, when I type that in and I hit enter, I get the right answer, which is, it's going to take a second to calculate, 1.59999, or in other words, 1.6, which is what we knew the answer was going to be. Yes, sir?
If we define the leg in our book, can we put like the b in the integral?
If you were to say b equals, that would be fine. I would be careful with that. That is often where you're going to get your points, is did you set up your integral correctly? And so for your work, sure. If it were the AP exam, take one more second and write it in. Questions on 6? These are the hardest ones, and I know you're not perfect at them yet. Hopefully you keep getting better at them as you go. Let's try one more. I think the hardest one is 5. If you can handle 5, you can do them all. Even if you can't handle 5, you can do pretty well. The answer is 12.566. You're trying to draw it out with your neighbor, trying to label everything you need. Notice that you are perpendicular to the y-axis. This equation is y equals, so you're going to have to rewrite that equation to make it an x equals equation. Okay, so you're going to have to do a little bit of work on that. Draw your picture, draw in your semicircles, make sure you understand what you're doing. Go. The base of the solid is a region between the x-axis and the parabola y equals 4 minus x squared. So that is this drawing right here. We are perpendicular to the y-axis, so we are stacking our values, stacking our shape, which in this case is a semicircle. We are stacking them on the y-axis. So that makes this a dy problem. That means I'm going to stack these from down here. You're going to have these semicircles down here. Oh, that's super ugly. Your semicircles are going to go across like this. That's like the worst picture I've ever drawn in my life. But you can visualize it, hopefully, even though I'm terrible at drawing it. When did I stack my semicircles for? What's the lowest number in this thing? 0, and I'm stacking it up until 4. This is a dy problem. You're stacking them vertically because you're stacking them perpendicular to the y-axis. And so it might be handy at the very beginning to make this problem fit what we need. Or in other words, since this is a dy problem, I need to get x by itself. So if I want to get x by itself here, what do I need to do first, Quinn? Okay, so he did this. He made it x squared equals 4 minus y. He added the x squared and subtracted the y. Cool. Then what? Take the square root. And so if he took the square root, his answer is going to be the square root of 4 minus y, but you got plus or minus because we took the square root. There are 2 parts to this graph. You have the right line, the positive square root line, and you have the negative square root line, which would be the other side. That would be handy. We are finding the area of a semicircle. So if I find the area of a semicircle, Nolan, what's the area of a semicircle going to look like? Yep, 1/2 pi r squared. Or in other words, all he needs to fill in is what his radius is. If he can fill in what his radius is, he's going to be successful. And so the last thing he has to do is find his radius. Well, I made my circles. I drew them poorly, but if I made a circle over here, I went from right to left. There's my semicircle, right to left, and so on. So my right line is positive square root of 4 minus x, or 4 minus y, and this one is negative square root of 4 minus y. So you could do one of two things. You could do this. Your radius is equal to your right line minus the left line. So it's minus a negative square root of 4 minus y. If you subtract a negative, what's that going to get you? Positive, so you have two of them. What is that actually telling you, though? That's diameter, so what would you need to do with it? A half of that. You would cut that in half, or it would just be that. It would be 2 times a half. Those things would cancel, getting you the square root of 4 minus y. You can do it that way, or to me, I want to do the diameter, or I want to do the radius. Well, where did I make the radius from? I went from the right line of this to where? 0. From there to 0. From there to 0. So in other words, I just wanted this minus 0. It gets you the same thing. It just depends on how you want to set it up. And so if I'm squaring a square root, those two things are really canceling. But in my calculator, I want to set that up. We're going math 9. We're going from 0 to 4. It's 1/2 pi r squared. My radius is the square root of 4 minus y. Close that parentheses and square it. And then it's dy. 12.566 is the answer. We knew what the answer was. We just agreed that that's the answer we should have gotten. Questions was something we did today.